Question 16a. A sector with radius 10 centimeters and angle theta is used to form the curved surface of a cone with base radius x centimeters as shown in the diagram. The volume of a cone of radius r and height h is given by v equals 1 over 3 times pi times r squared times h. Part 1. Show that the volume v cubic centimeters of the cone described above is given by v equals 1 over 3 times pi times x squared times the square root of 100 minus x squared. By Pythagoras' theorem, height h is equal to the square root of 10 squared minus x squared, where 10 represents the hypotenuse of the right-angled triangle and x represents one of the short sides. So we have h is equal to the square root of 100 minus x squared. Now the radius of the cone is equal to x centimeters. So substituting x for r and the square root of 100 minus x squared for h into the formula for volume, we have volume v is equal to 1/3 times pi x squared times the square root of 100 minus x squared as required. Part 2. Show that dv dx is equal to pi x times 200 minus 3x squared over 3 times the square root of 100 minus x squared. The following are the marking guidelines for question 16a, part 2. For 1 mark, we have correctly applies product rule or equivalent merit, and for 2 marks, we have provides correct solution. The first step is to express v using index notation rather than surd form. So v is equal to 1 over 3 times pi x squared times 100 minus x squared to the power of half. Now by the product and chain rules, we have v dash is equal to u dash v plus uv dash, where u is equal to 1 over 3 times pi x squared, so that's this term here, and v is equal to 100 minus x squared to the power of half. And it's differentiating v that requires the chain rule. So if u is equal to 1 over 3 pi x squared, u dash is equal to 2 over 3 pi x, and if v is equal to 100 minus x squared to the power of half, then v dash is equal to half times 100 minus x squared to the power of negative half, so that's the derivative of the outer function, multiplied by the derivative of the inner function, which is negative 2x, which equals negative x over the square root of 100 minus x squared. So v dash is equal to 2 over 3 pi x times the square root of 100 minus x squared plus 1 over 3 pi x squared times negative x over the square root of 100 minus x squared. Factorising out pi x over 3, we have v dash is equal to pi x over 3 multiplied by 2 times the square root of 100 minus x squared minus x squared over the square root of 100 minus x squared. I'm going to combine these terms using a common denominator of the square root of 100 minus x squared. I'm going to do that by multiplying this term by the square root of 100 minus x squared over the square root of 100 minus x squared. So that equals pi x over 3 multiplied by 2 times 100 minus x squared minus x squared over a common denominator of the square root of 100 minus x squared. And expanding this bracket here, that gives us 200 minus 2x squared, but then we have minus x squared there, so collecting the like terms, we have v dash is equal to pi x over 3 multiplied by 200 minus 3x squared over the square root of 100 minus x squared as required. Part 3. Find the exact value of theta for which v is a maximum. The following are the marking guidelines for question 16a, part 3. For 1 mark, we have finds the values of x at the stationary points or equivalent merit. For 2 marks, we have verifies that x equals 10 root 6 over 3 gives the maximum or equivalent merit. And for 3 marks, we have provides correct solution. Find stationary points by solving dv dx or v dash equals 0. Now since dv dx is a fraction that involves a function of x in both the numerator and the denominator, we can solve dv dx equals 0 by solving the numerator equals 0. In fact, a fraction can only be 0 if the numerator equals 0. So we're going to find these values of x which make the numerator equal 0. So we have pi x times 200 minus 3x squared equals 0. And we're going to solve this equation. Now, case 1, we have pi x equals 0, hence x equals 0. Now remember that x represents the radius of the cone. In case 2, we have 200 minus 3x squared equals 0. Rearranging this equation, we have 3x squared equals 200. Dividing both sides by 3, we get x squared is equal to 200 over 3. Hence, x is equal to plus or minus 10 times the square root of 2 over 3. Now, x needs to be greater than 0 since it represents the radius of a cone. Hence, a stationary point exists at x equals 10 times the square root of 2 over 3. Next, we need to find the nature of this stationary point, and we can use the first derivative for that. Now, v-8 is approximately equal to 11.17, which represents a positive gradient, so that's to the left of the stationary point, and v-9 is approximately equal to negative 92.97, which is a negative gradient to the right of the stationary point. Therefore, the stationary point is a local maximum. Finally, to find the value of theta, we're going to solve tan theta is equal to 2 pi times 10 times the square root of 2 over 3. Now, tan theta represents the arc length of the sector. So that's the diagram that's on the left-hand side in the question. And that's equal to the circumference of the base of the cone. So that's the diagram on the right-hand side. So we have tan theta is equal to 2 pi times 10 times the square root of 2 over 3. And we're going to make theta the subject of the formula. We can divide both sides by 10. So we have theta is equal to pi times 2 root 2 over the square root of 3. So I've just separated this third here and expressed it as root 2 over root 3. And we're going to rationalize this third by multiplying it by root 3 over root 3. And we end up with pi times 2 root 6 over 3. Therefore, theta is equal to 2 pi times the square root of 6 over 3. The following is the feedback from the Marking Centre for question 16a. Skills addressed: having a clear understanding of the steps required to show a result, using Pythagoras' theorem to correctly link the two given variables, showing their substitution of information into the given volume formula, listing expressions for u, u dash, v and v dash, and showing the correct substitution into the product rule, simplifying their expression for dv dx, showing setting out in logical steps, understanding the process used for finding a maximum or minimum value, and ensuring that they demonstrate a test to distinguish between minimum and maximum results. Areas for students to improve include writing a correct statement for Pythagoras' theorem and rearranging the resulting equation, using the pronumerals given in the question, differentiating functions requiring the use of the chain rule, manipulating algebraic fractions and leaving the result in simplified form, omitting solutions for dv dx equals 0 which are invalid, that is, x equals 0, showing numerical results when completing the test for the maximum or minimum value, and using their x value to find theta as required.